Okay, my friends, this is really exciting. I got this morning from a friend that sent me. He says, you're getting noticed more than you think, because I've been my channel is totally suppressed. So I don't get very many hits. And I'm thinking, gee, I got 230,000, something like that, subscribers. And I get a couple thousand hits. That's it. Then it's done. So he sent me this, and it's showing my hand holding one of these balls right here and my light experiments. And the title of this video is, he exposed the biggest cover-up in history, then suddenly died. Well, that wasn't me, but it was another guy. I'm going to show you. He claims to have been able to extract, I believe, I haven't really looked into it closely yet, but hydrogen and oxygen, which is water. Hydrogen and oxygen, you take the two of those as gases and put them together with a spark, whew, you got a serious explosion. And this guy claims to have been able to extract that explosive energy through cold fission, actually. They call it cold fusion. But it ends up being fission, then fusion, which is what we had here. And this was from the original experiments showing the particles, which are photons, which are from light using lasers. And I was doing a video today. This is just phenomenal. This shows up because I was doing a video called the neutrino laser. They want to be able to use a laser, but use neutrinos, and they can't figure out how to do it. But if they could unlock the mysteries of the universe. Well, so I figured, well, I'm going to do the video on it, because we did this 10 years ago. We created a neutrino laser. This is not a problem. And then this shows up. And then more shows up after this. It's just a cascade of, and they're saying these things are being deliberately covered up, and they're showing it as a real conspiracy theory. I don't see it that way. I'm seeing all these things are covered up, just like what happened at Fermilab and my work. And the same thing with CERN. I went to the University of Geneva for particle physics. We interacted. It came down to the, yes, I was right. You can see these particles with CMOS, complementary metal oxide silicates. This goes back to 2014, well, it started 2013, 2014, 2015. And I think 2015, I went to the University of Geneva online. And I explained to him, this is what we're doing. He said, you can't do that. You'll destroy the CMOS. And I said, no, we're using light. You guys are using huge things like this. And when they collide, they throw off chunks like this. That'll kill you, yes. That will explode. It will kill your cells. It will kill your bacteria. It'll destroy things. But when you're down here, where we were, this is what you see. It doesn't kill you. You got to be this small. You can have the energy. The energy is okay. But it can't be, the particle can't be too big, the black part. So you need a little tiny black part. And the only way to do that is with light, and then you do get that tiny black part. And you still get your light. And it can't destroy you and kill you. This should have been looked at very carefully in the beginning. It was presented very clearly, and it was rejected. And I see the rejection is self-interest and looking for funding and protect their job status, you know, how they're smart they are and all these things. Because I really went through the ringer, specifically with Fermilab, and specifically with a guy named Don Lincoln. And everything I will mention really relates to the interaction between Don and I, and these are my opinions about his behavior and what was driving them. And they're just opinions, because I have to draw an opinion. I couldn't believe that he couldn't understand these were the same particles he was showing. I'll show you what he found and what we found. There is just no difference. So yes, it's being suppressed, in my opinion, but not for a conspiratorial thing. I don't think. I think they present this as the guy was warned. He says, I was warned 5 times not to go public with this and so forth. And that goes way back. But I went way back too. This is my papers from 1970, right after I got out of the Army. These are intermolecular forces, 2 types, dipole, dipoles. Everything was dipole, 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 dipole. And then there's 2 types of dipoles. There's a fixed dipole. This is what I had back then. I got to go back through and look it over again. But then I had electrostatic interaction between dipole, which is a permanent molecule dipole, which is really stable. At that point, I didn't fully understand stability. And then you had a very rapidly fluctuating electronic density, which happens for 10 to the minus 13 seconds, yada, yada, yada. And the bottom line was the transfer of energy is from light to atomic vapor. And I don't care how you categorize light. Light is that white particle. That's what light is. Now I understand. Then I didn't understand. I knew it was the energetic part. So I called it light. Let there be light. Now, I'm going to drag you through this with me because it all makes sense to me, but I don't want to present this as a conspiracy. I know that the people I dealt with, and I dealt with every region of science because it's all wrong. And the reason it's wrong is because of peer review, which is meant to intimidate peers to fall in line and do exactly what you're told to do, or you will go out. And that's the real key here. I don't think it's like, I mean, it is a group herd mentality that you don't want somebody making waves in your pond because you have smoothed them out and you're above them and you're looking down at all the scum in the pond, which is us. And as long as you can pay enough money to Yale or Harvard or MIT or one of those, you're one of the people that they have suppressed. That's the way I see it. And it's just a herd mentality to protect their investment, basically. I think it's better if everybody had truth, personally, and we had free energy, possibly. That, to me, would be significant. Okay, I want to make something clear. Everybody says, "Oh, you should patent if it will do this." I don't want to patent it. No, it's not. It can't be patented now. Anyway, it doesn't matter, because I made this public, how it would work and how it would create electricity, and I was hoping that somebody would take it on, because this should be really cheap and it should be extremely energetic, and we can make life better in a myriad of ways, because just anybody could use this and develop it and make it more efficient and make more devices that they could sell. You're going to have these devices, but they're going to be able to generate all kinds of energy. I mean, literally, all we use to create what I'm going to show you is this. This is the phone, Samsung Galaxy S3 from 2012. This was a laser, and Rod Warren just happened to cross this by trying to do a double slit experiment using just this laser and other lasers, but the CMOS phone. And he was taking pictures right up close, and he I think was using the selfie one. I don't know. This goes way back to 2012, 2013, right in that area, 2014 maybe. And I saw the pictures he was sending, and I got a hold of him, and we worked together for years. And he sent me just scads of pictures. These were the original ones. When I saw that from the laser, I could see it was accelerating. And then he showed me one that really accelerated, and it did this. I'm going to show you these here right now. But this is the stuff that's been covered up. I agree with him. This is what we found right there. These are the same particles, and that's from Fermilab. This is 2013, and I got a hold of him. I said, and again, this is between Don Lincoln and I. It became quite contentious, and I said, we found the particles. Can we talk? No. He refused. You see this? This is what they're doing at the big colliders. They take protons, neutrons, they smash them together head on, billions of miles an hour, and they just get a zoo of particles. It's like taking this right here, which is a neutron, and if you had one less particle, you would have a proton. That's the difference. This is charged because it wants one more. A neutron is neutral. It has a full complement. They hit each other, they just splash. So what happens? You get some X's, you get some tiny, tiny, tiny pieces, some energetic, some less energetic, but these are photons. All right, so they see the photons. Identical, absolutely identical to the photons we see. We started with light. We started with these, and then we split these into these different red, green, blue, tiny little particles, and the black, which they have also seen. So here's Don Lincoln's article, which I responded to. Okay, this goes back to 2013. Now, don't forget, Rod bought that new phone, and he was just trying to do the double slit experiment, and he accelerated the light. He didn't realize what he did, but he did, and he started posting these pictures on Facebook or somewhere. I can't remember where it was, but I know it was actually, and so we got together, and here's the first set of pictures, basically, that started this whole thing off. And I'm just going to explain to you what he was doing. He's taking the red laser and he's shooting it through the air. Now, the only reason you're seeing this, you wouldn't even see that. It's a red laser, but you wouldn't see this at all, except that it's being sucked into this venturi, which is an accelerator. You see the wave here? It's coming forward, and there's a particle right in here, and I'll show you the particle, which I think I already have, which is this particle here. And that particle is coming forward, and it's making all the particles in front of it start to glow. You see these glow? That's this right here. So it's coming forward, and as it gets closer to the venturi, it starts to accelerate. It's just acceleration of light. It's very easy to do. And now we can see the actual particle itself starting to glow, gaining energy because of the pushback against its forward acceleration. The two of them hitting together right here, that particle, which I showed you, this particle here, thinks it just hit a wall. Right here, it thinks it just hit a wall. And it starts to glow like crazy as a photon, which gives you light. And it's coming backwards here a zillion miles an hour. And right there, you get fission, and then you get fusion over here. The white separates from the black. That's fission. These are the Higgs fields. That's another thing they made a big thing about. We found the Higgs fields. We got a cup coming out in buckets. And these are the particles right here. That's the photons. And this is the blue slowing down. I'm going to show you a bunch of different shots. And I'm going to explain to you the interaction between me and the rest of the world with this. Because when I get a topic going, I don't stop with the one guy or the next guy. I go to everybody. And I did. I put this to all the labs. I sent it out. Whether they got it, I don't know. But there was no interest. All right, so don't forget, this is 2013. We're taking pictures and doing all kinds of stuff with this exact phone. And you say, oh, Roger, you can't see all these things. Yes, you can, and here's why. CMOS, as I explained to these people, they had no clue. This is my background. Let me show you something. This is how CMOS works. The CMOS sensors capture photos by converting light into electrical charges. And every charge going up the spectrum, which is the light is nothing more than one of these frequencies coming at you, red, green, blue, whatever color. And all of that, each one of these tiny little spots, and I mean a bazillion of them, convert into different spectrum of energies. Basically, they're showing them colors, but we can only see this. All these other energies have have energy. But we only see this one here. Now, each pixel in this grid of pixels, and there's millions of them, contains a photodiode and amplifier. Well, what does that mean? What's a photodiode? Photo means pulse of light. Diode means it can go one direction, cannot come back. So when you hit this with light, these pixels, it picks up whatever energy is hitting it at that instant, and it appears to me that it's like it takes it for a period of time, which in the light world is I'll show you what it looks like, because it's not just one little picture. When it snaps it, we're getting pictures of light that are cascading down in what we would call a stacked layer. But because it's light moving, you can see it moving instead of the stacked layers. Now, each pixel contains a photodiode, which I say the light hits it, it goes through, it can't come back. And an amplifier. Amplifier means it sees a little bitty tiny bit of energy. It amplifies it into enough where it can show it energetically, like this right here. You see how that one's dim and that one's pretty energetic? That's because this one's coming through the air this direction, and this one is the one that's concussing with what's in front of it. This is just phenomenal technology. And then they go down to step-by-step how it works. The photodiodes, known as pixels, and the light enters the sensor, strikes the photodiodes. Impact of the photons on the photodiode generates electric charge. It's the white part that makes the electric charge. The more light that hits the photodiode, the greater electric charge it produces, the greater the intensity of the light. Now, and it's this, unlike the older CCD sensors, which is what everybody was using, each CMOS pixel has its own amplifier and transistor, which makes it extremely effective at capturing the tiniest bits and the highest bits of light extremely fast, because every one is on its own. It's not like an array. All right, now, plus it doesn't interfere. We're sitting off here with the CMOS. CMOS has no interference with the interaction. We're picking up light that would just keep going out into outer space or wherever it goes. It would just keep going by. So we're not interacting. When you use CCD, those are charge coupled devices. They're either sending energy in to see what comes back, or they're taking energy out to see what is in there. And they call that the observer effect. It changes it. Obviously, you're charged, coupled. CMOS is you wait back here for it. It just bounces into you, or it just goes somewhere else. But that's the beauty of this. There's no interaction at all. You just go like this, and a bit it hits it, and it's done. Otherwise, the CMOS, and they were doing this, and they actually thought just by looking at it, you were changing it. I'm not kidding you. That's how lost they were about this stuff. So charge coupled either puts energy in and changes the outcome, because the energy is nothing more than light, or they take energy out, which is nothing more than dipole electrons in heat form or whatever. So we don't do any of that. We just stand back. Way ahead of this by using CMOS. Now, again, this was the key right here, the CMOS. And Rod actually made a venturi instead of a double slit. He made the light come in together like this through a tiny little venturi, but on an angle coming together, so all the fields had to crush and out the other side. Now, don't forget, nobody can patent this. But anybody can make it work. I can't even patent it. Rod can't patent it. Nobody can patent it. All right, so that means anybody can use it to do this. And you could just buy these things. I mean, just lasers are cheap. They're almost nothing. And send them through the venturi and see what you get on the other side. Do some experiments. I'll show you what we did. Well, again, this is. Let's stay with Fermilab for a minute. This is Fermilab's pictures of what they see as the smallest particles that exist, which this is the muon, which is actually dark matter. They didn't realize it. Around it is the glowy color of whatever speed that was going at. There's the blue, the green, and the red is what we've used, the different lasers. Now, I think you're going to see all kinds of different colors because they're different frequencies. But different crystals give off the red, the green, and the blue, and they're just faster emission from the crystal. Pew, 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 pew. And that happens because of dipole electron flood theory. Right here, the tighter the particle, which is the light particle, the electron, the electron neutrino, the tighter that is to the nucleus, the faster it's going to escape. Blue, because you got to rip it harder away. Green is further away. You don't have to rip that quite so fast. When what we're doing is you're injecting more energy into there than it can accept. It just can't accept it. Now, there's certain crystals that are big and they will bounce off of here and they'll come off red. And then there's other crystals that are restricted more, let's say, and they'll give off green. And then there's other ones that are just like that. They're tighter than hell, and that'll give off the blue. That's the difference in the frequencies of light that's given off. And the blue is really, you got to whack that to get it out of there. All right, and down here is just, this is radio waves are way down the bottom where you just sound. Sound is nothing more than light going extremely slow. The frequency and vibration, frequency is how many little bips there are in a certain amount of time. That's all. Blue is just bzz. Red is green is it's all it is. Tesla was right, but exactly what it is. It's frequency of vibration. Now, just to establish some credibility here, you saw Don Lincoln's article here about the two particles, and these are the smallest ones they could find. That has all the mass, that has all the energy, and no mass, which I agree with exactly. And that was 2013. I got a hold of him and I said, Don, we've got your particles, and here they are. Here's his particles. I just showed you. This is clipped right from his thing. That one never changes size, has a glowy edge. This one can get big and get small. You see it? It's big and small, yes. This one's the same size. They never change. And the only way you can see these is when they're on top of a white background. You can't see these when they're in the air. They're like up in here, you just don't even see them. And now, what they wanted to find was the muons by themselves, these black balls. They never change size, the black balls. And then the white turned into showers. Yes, it's exactly what I sent them. And we accelerated the light and exploded it, causing fission. This is cold fission and cold fusion. These two come apart, the black and the white. Here they are right there. They break apart. The black just can't get through if you tune the venturi correctly. Now, I don't see any reason we can't harvest that white energy right here with photodiodes. And again, this can't be patented by anybody, so you can make devices and use it, I would think. And again, this goes back over 10 years ago. I eventually had to go to the University of Geneva to show them that they could use CMOS, and that started a fight between me and them, which I won. And they said, no, you can't use CMOS because you break the CMOS. I think I already told you this, but anyway, you don't break the CMOS with light particles. You break it with chunks like this. So what they ended up doing is using CMOS. But what they did is put filters in so that by the time they hit the CMOS, you just had little bits and pieces. So they lost everything. They might as well start with the little bits and pieces, as far as I'm concerned. Because you can't use CMOS with giant chunks. It's too much. These giant chunks, these X chunks are like this. That's like throwing a hand grenade at somebody. These are almost nothing. And these are the same as the photons I show. Some of them are higher energy than others they're showing. Same particles. They see the exact same thing we saw now. And like I say, this did not go well with Don and I. And I told him he'd probably wish he'd have looked at it better, and we ended we went back and forth many, many times. And these are the particles. This is raw white energy. That's raw electron showers. It's just the electrons. Now the black is trying to muscle its way in. It's all over the place here, but you can't see it. The only way you can see it is when it's on top of a white thing. Now, watch this one coming off here. It's coming in here splashing into black particles that are here. They're just everywhere, it appears. Because I believe it's when the black and the white combine. You get the field. And it happens at a certain distance out, the white slows down enough to where it can just splash. And that's the splash. Watch this one. Let's follow this one over. They all seem to go somewhere, these little splashes. Hard to see though. This one is pretty evident to me. And where does it go? It goes right here. See the black and the white, black and the white, black and the white, and then it turns into this circular pattern, which they all have that same deal going on. The white is the energetic part that's bashing in, and then like these here are on their side, they're being crushed sideways by other fields. Everything here is field to field. So it's sort of rippling a field across there. That's the cool thing about CMOS. When you take one shot, it appears to see all these levels all at once. And I can show you that with the blue shot, because the blue one, to me, makes it evident exactly what's happening. All right, we're coming in hot from the venturi. And you see the little dots, just one right after another. That's that same particle moving forward and drifting this way because it spins this direction. So it's slowing down. Quite obviously, you can see there's almost no distance even between the particles. And then they're opening up, opening up, opening up. And by here, you can see that there's two particles making that. Now, that's a single shot. And all of that is moving, because it's light, it's moving that distance. Well, you know, it's going to be a small distance, but it's moving a distance, all in a one shot. Versus just taking one shot and seeing one picture like this. That's the beauty of this. It's absolutely fabulous for doing this. See, the green is identical to the red, identical to the blue. All photons are going to have that configuration. And they're just going to have faster or slower speeds. And that I can show you factually right here, which is two lasers coming through at the same time at the same venturi, coming this direction. The red having very little energy, just gets pushed out of the way. The green just slaps it and actually creates a phenomena you just don't see. You see these little holes here, circles coming this way around? Let me dig in there close. First of all, just so you know, these are the same photons up here, and there's a little red blips in there. It's kind of hard to understand what's going on there, but they're just ripping the red to shreds. And here's the ripping effect, which is something you just never ever see, is the tumbling like that. You see those? You see those tumblers? You see that? You never see that, ever, ever, ever. They spin according to the axis of the Earth. They always spin like this, and that I can prove as well. All right, they never tumble like this. That is because these are going slow, and these are going fast, and they're just going, and they're just making them get out of the way, get out of the way, and they just roll out of the way. That's what's happening there. And then the green reconcusses back out here. Much, much more energy than the red. The blue is just too fast to do much with. But I'll show you that when the green goes straight forward, it spins like this, yes. But even when it goes like this, it still spins like this. It doesn't matter. Going this way, it still spins like this. It's always straight up and down. And they call it upspin and downspin. And here it is, right here. You see the angle this thing's going on? It's going on this angle. Why isn't it spinning like this? It's always spinning like this, with the pole heading to the south and the north. And then it turns into a photon as it slows down enough where we can actually see it. And there it is right there. Now it's charging up. This one here is getting charged right here, and it will flip, and the white one will come in front and start to absorb, and that's what causes it to flip-flop and spin as they go through the air. And I think I have shots. Well, here's some spinning here. Basically, this is the spin of them, and there's just zillions of them. They're just all over the place. This is coming out of the venturi. And again, Rod took virtually all these. Well, most of them. Some other people did take some. And I did some, but mine were worthless compared to what Rod did. And this shows the light spinning like this. And it's just there's a little ball on the end, which is a little light, and it's a dipole light particle. And sometimes they spin off that direction, sometimes they spin off this direction, but mostly they spin to the center. But there's a ton of them coming here. There's not just one. They're coming down with like a whole batch of spinning particles through that venturi. And the fields have to come together, and then they come apart, and they make these exotically excellent patterns because they're opposing each other. And you can actually see some of them crossing each other's patterns here a little bit. But they eventually make these stripes, which are you stay away, you stay away, you stay away, you stay away. And they create these lines, you see them? But it all starts with a spinning particle, or a spinning batch of particles, a lot of them, a lot of them. Now this one is light going this way, I believe. And this one is light coming right at us, the front of the wave of the light. Rod spent, I believe this came from Rod, but this is just stunning stuff. And this is the one where it's on a back splash, which is the typical double slit pattern where they show these, what they call interference patterns. They're not. They're repulsion patterns to keep these light particles away from the other ones, and they set up these white stripes, as I can show you here. There they are right there. This is light. That particle is light. That's not just a bunch of flappy waves like this that are going this way and that way. No. This is spinning light. Some goes this way, some goes that way. But every charged particle says, you stay away from me. That's what creates the showers. And it creates these lines until they can get filled back in with the dark matter. That's those dark matter particles right there. Separated from the white, joined back together here. It's impossible to miss this. Literally impossible. That's the collision spot. That's the fission. After the venturi, which you can't see, it's the tiniest little, but this is just like an atomic, it is a subatomic explosion because it's breaking the two particles apart. That's an explosion. And they come back together here, that's fusion, fission, fusion. And here it is right here. And the only way you can see the black is if it's on top of the white. There's black right over in here. There's black all over in here. But it's got to get in and grab a hold of that white. That's what it's trying to do. And when it's sitting on top of the white, you can see it. Otherwise, you can't see it. It's dark matter. It's solid. It's matter. It doesn't get bigger. It doesn't get smaller. It's like a bowling ball. It stays that same size every time. You make that little lane there too small, it bounces back. And the white can get small, and it shoots through, and when it comes out the other side, it's like spraying a hose. And basically, it's the exact same thing as taking a venturi on a hose and spraying out the other side a high speed of particles that came in that were crushed and had to force each other away from each other. Almost identical. It's a venturi. That's all a hose is. But anyway, this was sent to Don Lincoln at Fermi. I was very, very upset. And, you know, they cut you off, you can't talk, and that's it. Now, he also did say that exactly what I was saying, empty space isn't empty. These particles are light particles. They're not nothing, they are light. Light makes up everything there is. As a matter of fact, I showed this, I think. The transfer of energy is from light to atomic vapor, atoms. It's the vapor of atoms that make up the atoms, and that's dipole electron flood theory. And just so you get a little more credibility here, you know, these guys want to say, well, you went to this school, that school. That's fine. You can go to any school you want until you realize that light is atomic vapor, and there's nothing but two types of energy, dipole, dipoles. I've known this forever. And I was looking at non-polar molecule, uncharged molecules, very rapid fluctuation of electrons. I got to go back through all this stuff because this is what I came up with back then. Now, I had papers here, as you can see, quite well shopped. All kinds of stuff about what light is and, you know, all of the different experiments they did. I did everything, all the chemistry, all, you know, everything, all the electrostatics, the bonding, the molecules, on and on. This is a lot. And not only did I do that theory stuff, I did actual experiments showing the heat of radiation, the heat of solution, the heat of whatever else, all these different changes in energy levels and so forth, and came up with conclusions about it. And I think the last conclusion I came up with was, here it is right there, electric power. All power is electricity. Electric energy in joules. That's all there is electric energy. Because electrons are the things that move everything. They create the energetic values. And I've known this forever, and thank God to Rod for actually showing me. Here's the first picture I think he sent to me. And when I saw that, I said, whoa. See, there's the phone. There it is right there. This is a pinched blue one, a red one. They come through in the same color because that's their energetic value. Now, it appears you can change their energetic value by crushing them even as they're reforming, because blue is a higher energy level than the red. So we've crushed the red into a blue, and you see it coming out, and now it's opening back up again, but these two came into the sides of it, crushing it. And I've seen some other ones that are just phenomenal. You saw that one. We can make these Higgs fields all day long. When they get a handful of them, they think it's a big deal at the colliders. But we're just working with the raw light. We can see every little detail of what we're doing, every detail. And here, of course, there's the red, and it's flat like this, or they're like this. See, like they're starting to increase in energy. Let me turn this off. All right, maybe that makes it better. I don't know. All right, here they're coming in from, and they all do the same thing. Only the red, you can actually visualize it because they're slow. It's coming in, heading towards the venturi. The venturi's right here. This white area here is pushed back from the venturi explosion. That white is now going this direction. The light is coming this direction. The photon means that a photon means it's light. It's like it's giving off light. And it's giving off its own light here because it's hitting its own field. And this whole area is starting to glow. Now, you see up here? You see back here? Well, what do you see here? You see nothing. Nothing at all. Zero. And what do you see here? You see this stuff coming through. Let me see if I can move this up. No. You don't see anything down here. Nothing. But you do see coming straight down here, the particle is getting more and more photon-y. All right, it's more like a photon. And right here, they all start to glow, those fields that are coming in an arc like this, because this is exploding backwards in an arc, just like that. All right, can I show that? Yes, I can. Here it is right here. That's the explosion. All right, very grainy looking on ours. And right starting back here is where these fields are starting to glow like crazy. They're here. You're never going to see them. You would never see them out here. The only reason you're seeing them is because of the pushback. And you see back here, that field back there? That's what they call reverse EMF. I dealt with this when I was in the electronics. I was a field engineering manager for division of Walter Kidder Corporation. It was Victor Business Products when they first acquired them. But anyway, I had to deal, I was a field engineering manager. I had to figure out why things didn't work when they hit the field. And one of the biggest things was the voltage of the chips was too high when you went down to a very cold temperature. When things are cold, a lot of flow of energy. They had 17 volt chips. We had to go down to 5 volts. Well, they used them, but you couldn't use them in a cold. You couldn't bring them in from the cold and plug it in. The chips would explode. And you could look it up. General Instruments was the chip, and it's 17 volts, and it was just too much. It couldn't handle the cold temperatures. They would pop. So anyway, and I was the first one to put those in. They came into Connecticut, and they didn't work. Anyway, this is the particle, and that's where it explodes right there. That's fission, and there's fusion. And right here, I think we could put in a harvester. And I've shown this for a very long time, so it's not something anybody can patent. You see this? Now, don't forget, I think it was 2015, it might have been 2014, but it was right in that area. I went to University of Geneva, who is intimate with CERN. And I told them about the CMOS. So CERN experiments began integrating CMOS in the late 2010s, which means 2019-ish. 2016, I think they started looking into it, maybe, I don't know. But with the ALICE experiment replacing the silicon tracker with CMOS, all right, the system during the 2019-2020 long shutdown, they had to shut the whole thing down and replace these detectors with the CMOS. The CMS experiment upgraded its pixel detector in 2016-2017. Now, again, they told me they couldn't do it. It wouldn't work. There's no sense in even thinking about it. I said no, and by the time we were done, they didn't disagree, and then all of a sudden, they're upgrading to CMOS. Upgrades prepared the experiments for the increased data rates and luminosity of the LHC's future runs, particularly high luminosity LHC. The luminosity of our experiments is there is no more luminosity you can have. But we're using light, so they're still using these gigantic particles. Now, what is that luminosity going to do? I don't know. But I do know they have to make it so that it was hardened. All right, so phase 1, phase 2, Alice experiments, future LHC upgrades. But it's all about incorporating advanced CMOS technology to handle. But they have to make it so that it's hardened. And I don't think they're going to get as good of information as we are. We didn't have to harden anything. We're actually seeing the exact particles and exactly how they interact and split and come back together. And when they do, how much energy you can get from them is staggering. Staggering amount of energy from almost nothing, as far as I'm concerned. Electrons don't exist. Physicists conducted a new experiment, confirms it. Electrons don't exist. Well, in dipole electron flood theory, here's what an electron is. Well, you know, the white part is basically the electron neutrino. Now, I call them dipole electrons because they're always going to be attached to a black one. Always, 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 unless you do what we did, which was split them. And that's very hard to do. That's fission. All right, so these really are electrons, and they are just energy. There's no mass to it that I can find. And these are the tiniest bits that are fixed matter, and you take 1,839 of these two of them together, they make one proton. One proton. So they can be split all the way down to here. These two are normally always together like this. I would call that a dipole electron. All right, it's always a plus and a minus. And they call them Dirac neutrinos. Well, that's fine, but I would have always thought of this as a dipole electron, and I still do. Now, two dipole electrons together have a form of stability, which is a photon. And that's what light is. And it's pretty stable. Now, it will hit things, and some of it may incorporate into the thing it's hitting and warm it up. Yes, we know that. Light warms things up. And it's because of the energy levels of the thing that it's hitting. Some things reflected, and there's virtually no... Anyway, people know how light works. It warms things up or it bounces back, whatever. That's light. That's electricity, basically. Only that is the raw electricity. This is heat. This would be considered heat. When you put the two pieces together, and when something gets warmer, guess what? It gets hotter. You think if something gets hot, it gets going up in the air. Only gases. If it's a solid thing and you add heat to it, it will increase in its weight because you're putting more of these dark particles, which are nothing more than the gravitational particles. The dark is gravity, and the white surrounds everything. So everything there is surrounded by white. There is nothing that exists where you can see the dark matter on top of the white. You just can't see it. The white surrounds everything there is. There is nothing. Your fingernails, your eyeballs, the tip of this feather, every single thing has the glowy particles on the outside. That's the key to dipole electron flood theory. The dark particles always go to the core. And it is somewhat similar to the standard model that you have a solid dark core, basically, and some floaty little electrons on the outside, but they only have a handful. Ours, or mine actually, is gigantic of just these particles. And they're going to be at certain distances of stability based on whatever that particle, that atom happens to be. And they just get bigger and bigger and bigger. Hydrogen is the tiniest, small, and that's nothing more than a proton, basically. It starts out at about 1,839 of these little electrons. Anyway. way I've shown it before. The little ball of electrons I show is nothing more than this. And you get bigger and bigger, and they add more and more, and they seem to be at a certain size, they become stable. And it appears to be like moving up the line 1839 or so. And then they throw in a whole bunch of neutrons. It gets very confusing the way they do that. But basically, this is nothing more than what an atom looks like. And we're down here using this as light, which are the black and the white ones shining from lasers. So we're not causing the damage they do when they use those big bombers and see nothing but literal debris. They call it a particle zoo. It is. They see them. They have no idea what it is. We started down here, so we see them breaking apart and see them coming back together and see the Higgs fields, and we see this one particle that is kind of hard to explain. That one right there. They're all coming off with these. You see how they're shooting these little rays and turning into these? That one appears to be spinning backwards. The other ones are, well, I don't know. But I think that is the one that created this very, very strange effect here. I think that is that particle. And that is the interaction when it hits a standard field. Now that's the kind of physics I'd like to have somebody explain. I know exactly what I see here now. I'm almost certain of what I see and I understand. And this is about as deep as you can get into particle physics. That's beyond dipole electrons. That's sub-dipole electrons. But I can explain it if somebody would like to hear the explanation. And this right here, this is where they interact. This is electrolysis in space, I believe. And this was a ball of, I think, fluids, some kind of fluid. And they were pumping electrons into this fluid, and the electrons were expanding. I'm pretty sure. I don't want to make any crazy statements about that, but I think that's the way, this goes back years and years ago. And the Russians did some stuff in space too, extremely cool. They created this black hole and they freaked out. During the experiments, we contacted the Earth guys, couldn't believe it either. This is another one that proved, this is 2014, 2015, I think 2014. They were up in space and they injected these into a vacuum chamber. Nothing in here whatsoever, supposedly. And they put all these charged particles in, and this is what they saw. They went in all like this, and then it went badoof, 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 and it made the hole. And it's somewhat flat because there is still gravity here. If that was way out in space, that would be a perfectly round hole surrounded by these particles. And the more particles, the bigger it would get, and bigger and bigger and bigger. Because it appears that the black somehow gets in with the white. I don't know. I really don't know. In space, I don't know what happens out in space. Do they come with the same number values? 1839 makes a stable proton? I don't know. I really don't know anymore about what happens in space, but I can tell you what, that happened, which proves to me or shows me that the central core is dark matter, just exactly what dipole electron flood theory is. There it is right there. That's the thing, same thing they saw in space. Dark is in the middle. It doesn't reflect, absorb, or emit. Now what they were doing, I'm sure, was shining a light into there to make these particles glow back. Let's look at it again. There's nothing here. Absolutely just totally black. Nobody could account for that. That's dark matter. And these white ones were bouncing in against it, trying to attract to it, forcing it into that central core. Now, this is This to me, it looks like atomic dark matter. There is dark matter that is subatomic. That's the stuff we're working with. This is in a big realm. I can't explain this, but it's pushing all those dark particles into the center. I know there's dark particles all over here too. They're still here, but somehow it's forcing them into the center. I just, you can think about that one yourself, but this is tricky stuff, and that's out in outer space. And then we got pictures like this from Rod's nephew, Dylan. What is this all about? And this, again, CMOS. And then I'm working on another guy, Mason, right now. He's got a Newtonian telescope that he's doing some fabulous work with, seeing things that nobody's really paid any attention to. And then they're all dipoles, just like this, all dipoles. Space is all dipoles too. Dipoles, 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 dipoles. All of those fields, all of that stuff is explained with dipole electron flood theory. All of this is explained 100%. And again, this is not something I just cooked up in the last couple of minutes. It's been going on for a long time, and even in the last 10 years or more, trying to work with Fermilab, all of them. And I've sent this to all of them. And I know now that somebody's paying attention, at least this channel is, that shows them I'm out there holding that particle, and they're saying people never gave up on this, even though it was crushed. And that's what has happened to me. I've been crushed. All right, I got the sound off. I'm just going to play this. You can read what it says, and I'll read it as it's saying. They're saying the suppression of all of these things, especially the things that I've been showing, some of the greatest crimes against humanity is to suppress these things. So it says it was one of the greatest crimes against humanity ever committed. Now listen to this. All right. The verdict was final, but the truth has a way of clawing back from the grave. And in hidden labs across the world, the silence began to crack. Even after the U.S. government and major universities declared cold fusion dead, not everyone walked away. All right, in Japan, Italy, and a handful of smaller labs, and they're showing me holding that particle and dipole electron flood theory, and as I showed you, we can do this. All right, a handful of smaller labs across the world, researchers quietly kept experimenting. Now, there's other ways than mine to create energy that's excessive, and I agree. Hydrogen, oxygen should be a way to change that into gaseous, explosive particles. It should have been done long ago, I would think. However, I believe my way with the venturi, and what they were just showing here is the way to do it. All right, right there. We can split those, and in the meantime, grab a hold of that white. Well, let me show you my mock-up. All right, this is, I showed you with the laser, and the black can't get through, the white gets through. If it could hit a photo receiver here, down through a photodiode, which we were talking about before, which means it can only go one way and not come back, we would have to have a whole batch of, I believe, thin film transition metals and so forth that can receive all of these different energy levels, send them down into a battery, or just send it right out to be used with a floating ground. And that would be, you could put it in something like this and have all kinds of different outputs, anything you wanted. Now, this just shows you, this is from, I think, CERN. I'm not sure, one of the big places. And they're showing the electrons coming in, which is the white ones, through the venturi, creating these enormous, from lower energy to higher energy showers, right up through the roof. Now, these are the muons, the black particles. So don't forget, these are the electron, white particles. These are the muons, the black ones. They come up, they bang, and they bang back. They don't go through. And we can tune ours so that nothing but the white goes through, and the black, none of the black goes through. Now, what does that do to the energy? What does that do to the energy at this spot right here? What happens to the energy? Well, here's what happens. All right, see this? This is base tracks at the shower max layer. All right, so what is a base track? It's each one of these particles. Now, they're showing this is the energy. Max U means energy. This is the max number of electrons. All right, so it's coming in, and it's getting more and more and more electrons as it's building up against itself. We've seen it getting wider and wider and wider, and right at the energy, at the venturi, it has to force itself through, and they go right up through the roof. That's the number of electrons. We're way up here. Now, what happens at the energy? Same thing. Very small amount of of energy. It started with almost no energy, but at that venturi, it's way up here, 3,000 times. 3,000 times more energy at the venturi. That's what they say. That's not my words. So what if you were right here at that venturi, smashing that right into a photo receiver, just like a solar panel, getting 3,000 times more energy than normal? Well, you'd have a circuit. You could drive all kinds of things with that. And you could have as many stacked, inside of here you could have dozens and thousands of these. These are all infinitesimally small. And you could have a big bus collector that would bring it down into whatever you had to drive with it, and it would be portable, walk around, it would only be used when you're using it. But you could use it to power offshore grid. You could do anything with it. You could walk around with it handheld. And you could put like all kinds of different outlets in there. AC, DC, anything you want. ZZ Top. I believe I've shown a pretty good, evidence for what I say. And this was, again, I was really upset with Fermilab, and all of them I was upset with, but Fermilab was the real killer, because they almost always do this. If anybody will speak to you, they'll put you off to somebody else. They'll say, oh, you're going to have to talk to so-and-so, or he's the guy, this is the guy. And that's what happened to me at Yale for my Mudfossils, and that's what happened to me here was Fermilab. And then, so I went around everybody by going to University of Geneva and going directly to the source. And again, they upgraded to CMOS. The same thing I told them. I said, you can do this, and you're going to see everything much better. And the key here with them is, for them, it's not good enough to see this. They want big chunks to do something like this, to do some kind of exotic fusion or whatever they're going to do. Dangerous, dangerous, dangerous stuff. They have to wear badges when they go in to work on these things and be around these experiments. They can only take so much of this energy before it destroys their body. And they're hitting these things, these people with chunks like this all day long. Whenever they're in there and they're shooting that thing around. These particles, some of them are whacking you. They might have enough hardening to keep the big ones out. But they do wear badges, and the badges fill up, and then they have to stop. That's my impression. Maybe I'm wrong, but that's what I've been told and heard. And when you're working with light, unless you get right down there into the mix, you'd have to be right in here to get into where it would bother you or hurt you. I think if you were back here, it wouldn't bother you at all. It's nothing more than light. But where it focuses, it's you know, as a matter of fact, I was doing a video on the neutrino laser. I think I'm going to do a separate one on that, because that's how this whole thing started. I was just doing the neutrino laser, and this thing pops up about me being in this video. Jesus Christ. I'll tell you, every day is a shocker du jour. I'm going to leave it. Whoops. This is just bizarre. This is a friend, Tom, who I have never met or heard from before, but, you know, I consider him a friend. Some people don't like using last names, so but anyway, he said, you're being noticed more than you might think. See, at 1639, the following video, his testimony shocked MIT and Washington, then he died. Well, again, I don't really go with the conspiracy part, but I'm to tell you right now, they suppressed the hell out of everything that upends their superiority, their status. Against the people, against the students, it doesn't matter. Truth has no place in peer review. It's no place in peer review. It's herd mentality. You say what everybody else says, or they'll destroy you. That's how it works. I mean, this is just so bizarre. I was just doing this video. Physicists propose a neutrino laser straight out of science fiction. We've been doing this for 10 years. The ghost particles, MIT, and all these people. Yeah. We've been shooting out laser blasts for a bazillion years, neutrino. It's 10 years that we could see them. And just using a standard little laser, no big deal at all. Very, very simple. Very, very simple to do. But you got to put it through the right kind of venturi. And then you get a neutrino laser. This is just beyond belief. I was just in the middle. I was just finishing up on the neutrino laser when this thing came in from a friend about them talking about, you know, fusion and fission and fusion, and being noticed. All right, so everything I've been showing you is related to neutrinos. Muon neutrinos, electron neutrinos. You got to separate them apart, and they want to use a neutrino laser. They're proposing it straight out of science fiction. That's what I was just showing you. I was showing you neutrino lasers. You take the laser and you shoot it through the venturi correctly, and you focus it correctly, you end up with a neutrino laser. The neutrinos come out the other side. So it's just bizarre that I was just finishing up with this. Now, that's going to be a separate video, because it took a lot longer to do this one than I had expected. But I wanted you to understand, nobody can patent this, so anybody can do this, can figure out better ways to use this type of technology, this venturi technology using lasers. It's for the good of humanity. It's not, you know, the problems we have are serious. And a lot of it relates to energy. The more energy, if we had free energy, just think of the change, instantaneous change. And you could do this within a couple of weeks. These could be out running in the field. All you're doing is shooting a laser light through a venturi, collecting it in basically a solar collector, through a photodiode into a stack of whatever you want, or run it whatever you want, handheld. It's the way to go, my friends. Now, if they kill people for wanting to do this, well, I'm not putting it out of possibilities, but, you know, life is life. You only last so long. And here's what they're saying right here. Look at this. Physics of electron showers. They want protons and then hadrons and this and that, and some creating flux and all that. Well, we started with the neutrinos. We didn't have to create all that stuff. We started with them. And they're saying the energy of neutrinos within this thing goes from 100 billion electron volts to a few trillion electron volts. absolutely stunning increase in energy. Stunning increase in energy. That's energy. All right. So I think it's time to look at this, but again, that's just me. And I do think that it was a disgrace, in my opinion, the way Don Lincoln handled his chores. And they are chores. He's supposedly a fiduciary working for us in our best interests. We give him a whole batch of money. He's on daily, basically. Or he was at one time. I haven't followed him in a year or two now, because we just parted ways about a year or so ago. And this goes on for 8 years. And I couldn't get anybody to talk to me either, anywhere, even nowhere. So maybe President Trump will see this and say, you know, we're spending trillions of dollars. By the time you take this back 10 years ago, the amount of money spent is incredible. And the same thing on the Mudfossils. And the space exploration, what's on Mars and so forth. All of this stuff relates to Mudfossil and dipole electron flood theory. So I'm going to leave it at that. It's time that we work in the best interests of society and not in the best interests of peer review and keeping them suppressing any new information that rocks their boat. We're all in the same boat together, and it is rocking, my friend. So let them take their knowledge and work it into this knowledge and see if we can come out with something that can help. That's all I'm asking for. It's all I've ever asked for. I don't want anything for myself. I just want people to understand we're being misled by the ones we trusted. That's my opinion. And primarily it's the schools, the universities. Absolutely horrendous. Because if you don't say what they tell you to say, you're outside that gate and you're a pseudoscientist. They keep saying you're not peer reviewed because they won't peer review you. Nobody will look at this. Not a single person will peer review me on this. And I've asked for years. And every time you ask, you're rebuffed. They won't do it. Okay, my friends, this is currently the biggest mystery in physics. These are the Higgs fields, and that little particle right there, that little white one, I believe is antimatter, or it's an anti-spinner. Is it antimatter? I don't know. Let's see if we can follow its trail into what it becomes when it interacts with matter. Okay, I'm going to start this off by the biggest mystery in history. What is that white particle? This is from a venturi, and these are Higgs fields being propagated as that light, which was the electron neutrino, joins back with the muon neutrino. They form Higgs fields. That little white particle, I believe, is this little white particle here. Every particle I've ever seen creates the Higgs fields like this. This is different. That's different. And what happened here? This is the biggest mystery in physics history. All right, we start off with a field like this, which is a light particle coming through the air, causing all other particles in the air to exhibit some form of an energy release. And that's what the CMOS is fabulous at picking up, is these energy releases of any of the tiniest little amounts and exactly where they are. And because we're using light, it's picking up a whole series of pictures at the same time because the light is passing through those diodes. All right, that's why you can see this, where the light is accelerating. This is just one picture. And it's because we're moving forward at the same time that picture is being bounced back at us. And we can see the particle accelerating, we can see the explosion, we can see the fission and fusion. And everything starts out like this. Well, guess what? It ends out like this too. All right? When you create an energy field that you can see, that has enough energy that it's given off a field, that's what you're looking at right there. Well, guess what? Right over here, you get exactly the same thing, only you get it on steroids. So I'm saying this field hitting this, creating the outside end, which I'm going to show you right now, I can't see how it's not an increase in energy. All right, this is right here, that little spritz coming through. Well, coming off of this side, what do you see? These are all these Higgs fields. These are the same fields as the light. They're basically the same identical fields from when they came in, and then they split. Now they're coming back together, and you get the same field. Before they split, they were just like this. Same fields. Only we're just starting to see it. As it accelerates, we see this happen. It's, and it takes off, and the particle actually pulls itself right out of its own wave, which is the magnetic field. I mean, this is really exotic stuff. And right here, it's all bets are off. Everybody explodes together. And you can see every one of these is a field. They're here, you just can't see them. But then on the outside, when they come through the other side, you got these same fields. And here they are coming at us through that venturi. This is what we're seeing, these same fields. So from one side to the other side, it's the same. Only these are like bucket loads of them compared to what we started with. I would say these are the electron showers. These are the electron showers, as far as I'm concerned, and that's what they're looking for, is the electron showers. Here they are, sterile muons, here they are. Light acceleration, there it is. Wave, particle duality, explained. Dipole electron theory, 100% supported. And this is all based on the same thing they found at CERN and Fermilab and all of that, which we found basically at the same time. There's the article, 2013. This phone is from 2012. I can't remember exactly when I did get a hold of Don Lincoln, but again, this is not right. It's just not right the way he handled it. And that's my opinion. What his job was, I think, was to act in our best interest as running Fermilab. That's government money. And not only that, I contacted all of them. Nobody was interested. Not a single word of interest. I was told I was wrong. And Don was he was abusive as far as I'm concerned. He called me a tinfoil hat guy and an embarrassment to science. And finally blocked me, and that's just what happens. That's just what happened. I mean, there's no question about that. And my opinion is that it was self-serving, not to serve us. If you can't tell that that's this, or even have one question, not a single question, no question whatsoever, you can't do it, you're wrong. I said, wait a minute, I am not wrong. What do you see that you can't? Those are interference patterns, you don't know what you're doing. Leave it to us, we know what we're doing. I said, no, you don't know what you're doing. Then it started a fight. And then I ended up going to the University of Geneva because I said, you guys, you're not doing this right. And once I was a student there, they had to basically interact with me. I went through Coursera. I went through all kinds of schools because I went to confront. I went to confront these teachers. And then, they all gave me the same thing. Oh, you can't do this. Well, this changed. University of Geneva changed everything because CERN actually upgraded to use this technology. I'm not kidding you. I'm serious. All right, I just showed you a stack of evidence that supports my theory, but you go to automated indoctrination, AI, and they say, no, dipole electron theory is not scientifically accepted or correct theory. It's a fringe concept, contradicts everything. Well, yes, because everything is wrong. Theory is not supported by the vast body of evidence and widely accepted models. No, accepted, yes, but they're wrong. And then they go by why it's considered incorrect. Well, here's why. They say there's a lack of evidence. There's no experimental evidence of theoretical basis to support the claims. No, that's totally wrong. I just showed you all of the claims and all of the evidence and the same particles as Fermilab found. There's a lack of ability of the people that we have in charge. And Fermilab, I'm telling you, I'm sorry, in my opinion, Don Lincoln should be removed instantaneously and rebuked terribly for his dismissal of evidence that was literally undeniable as far as I'm concerned. That's my opinion. And this is 2013. Now, that's a long time. And the same thing happened with Yale, with my Mudfossils. But Yale actually took credit for my work. In my opinion, they just used my paper and got paid by NASA. This is just a big game. As far as I'm concerned, I'm seeing no interest in actually doing their work. I guess I'll leave it at that. Thank you. I love you all.